All right, our last topic under our conic sections will be circles. I think some of you have worked with the circles, whether it be in first section or on your own. You have a little more idea about them in geometry. Obviously, we studied them as a two-dimensional shape, and so we know some characteristics about circle. But take a look. We're going to write an equation for a circle, given sufficient information. And given an equation, then you should be able to graph it, label its different parts, radius and center. So knowing what you did in 9.2, that was the toughest section about all the different pieces and parts of the parabola. Now the circle should be quite a bit simpler. Circles, we know, are a set of points in the plane that are equidistant from a given point in the plane called the center. Now remember, this came from that double cone with a plane running parallel to the base of either of the cones. And that would give us a circle versus an ellipse, hyperbola, any of those. So this is that circle. Now, if we took, and just from geometry we should be able to do this, identify the center. We should know that point equidistant from all parts or pieces of the outside edge. And then our radius would be that distance from the center to the circle to the outside edge of that circle. So should be able to do that quite nicely just from geometry. But now we're going to look at, here is that equation of the circle. We've actually graphed several of them, and we could sort of make an hypothesis about what the equation is. But now here's where it's stated. An equation for the circle with its center at 0, 0, and a radius of r will always be x squared plus y squared equals r squared. If I said, what's it look a lot like? Most of you would say the Pythagorean theorem, just different variables. So x squared plus y squared equals r squared. Notice there's a coefficient of 1 in front of each of those variables. There's not a coefficient of anything else. Now r actually will become a number. So r is not considered a variable in this equation. X and y are. So first question you can see says write the standard equation of a circle whose center is at the origin and whose radius is 4. So brain says, based on what we just did, x squared plus y squared has to be the center, or the circle, and r squared, r is the radius, our radius is 4, so r squared can be done quite nicely. We would get to 16. Let's say if it was not a nice radius value that was given to us. So what if they said the square root of 10? Well, then you would square that number and you would still have a fairly nice number. All the radius squared values do not have to be perfect square numbers. You can have a circle that has a radius that is non-whole number. Now, if it says sketch the circle, well, start thinking. We know the center's at, boom, boom. You know you have a radius of 4. From center, you can go to 4 quick and easy points and then draw a nice curve if your hand is good. If not, you can approximate what those look like, and hopefully your vision of this one looks something like that. Okay? So x squared plus y squared equals r squared. If we now take our circle, just like our other shapes, and translate it, which we know is a slide in any direction or any combination. Could be just left, just right, just up, or just down. We would get a new center, and we've been calling that new center HK, no matter what we've been working with, whether it's translating a line, translating a parabola, all of these different things. HK has been that new movement to stand for the movement H, which would be the movement on our x-axis, and K would be the movement on our y-axis. So right now it looks like I moved a positive set in both. So I went over H, positive, then I went up K, positive. And as you can count, 1, 2, 3, 4, 5, 6 was my movement H. 1, 2, 3, 4, 5, 6 was also my movement K. It does not have to be equal movements for h and k. We've moved before where we moved 3 one way and only 1 the other. We've moved 5 one way, none the other. So be careful. We still had our base equation, remember, of a circle. At 0, 0 was x squared plus y squared equals r squared. Okay, if the center was 0, 0. So if we know our center is at 0, 0, in our new equation, we just said our center has become hk. So that means our radius has to have that hk combination in it. Or sorry, not the radius, the center movement. And so hk is exactly like we did it with point slope. If there's subtraction in the original statement, then the values are as is. If there's addition, it would be because h or k had to have been a negative move from the beginning. So on this one, with our 2 6's, our new equation, and then we'll have to count the radius. We didn't do that earlier. We'd have, whoops, let's not write with the highlighter. We would now have x minus 6, because our move was to the right 6 squared, plus our y value is also 6, so minus 6 quantity squared, has to equal r squared, our radius. And if you look at the picture carefully, I'm not sure, unless we would do a squared, b squared, c squared, that we have a radius that we're going to get here. So we could do, because our radius, our center is at 6, but our radius is definitely not 6. And there's no information here to tell us we'd be doing, you know, hk movements. So all we'd need is our radius here, and we'd be good to go. Square it, done. So let's try one that we can do because we have enough information. And it's coming in now. This one says, complete the problem by finding the missing parts. They gave you the equation, actually, and now you have to find the center and the radius. So doing that, I look at the x value, and I notice there's a plus sign. I look at the y value, and notice there's a minus sign. The x number comes from the x parenthesis. The y number comes from the y parenthesis. It's not difficult. We don't try to trick you. And so we need that center, that new move, that hk value. That hk value in this case is negative 7.5, comma 23. What is the radius? Well, remember, the equation used to be x squared plus y squared equals r squared. That's the part of the equation that's not changing. So our radius has to be 7. And it would be 7 units because they don't tell us anything about feet, inches, miles, or anything like that. So now that we have exactly what we need, we could draw a very accurate graph very quickly without having to rewrite that equation. So you could place your center at negative 7.5, 23. And from that negative 7.5, so, you know, just eyeballing it here, if we said we were at negative 7.5, so over here we knew we're at negative 7.5, and then we went up to 23. So up here quite a ways. We'd have to have a different label, wouldn't be by ones. So if we're over at negative 7.5 and you want to quickly get your point, you could add 7 to the right. You'd be at a negative a half. You could add 7 to the left. 7 with a negative 7.5 would give us negative 14.5. And I'm just approximating. Obviously, I need a piece of graph paper here to get a little bigger. We're at a positive 23, so I could go down 7. 23 take away 7 would leave us 16. And then 23 plus 7 would give us 30. And you can fairly quickly draw a very accurate picture. I can't draw circles as well, though, of what our circle looks like. Okay. Next, and last but not least, I believe we're going to be taking a standard equation from this translated circle below. So here this time you've been given the graph. You have not been given any numbers or anything, but definitely been given the graph. And there should be enough information there. So let's find the center. Ask yourself, where is that center located? Be careful, find your 0, 0. Use that as your guide. So we're going to jot a few things down. Our center is at the ordered pair. Count carefully. What did you get? I'm looking at -2, +3. We have to assume everything's by ones because it wasn't marked any other way. And so now, the last but not least, let's check our radius. Our radius equals, we're looking for whole numbers if possible. If not, but based on the grid, 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the left, 1, 2, 3, 4 down and up. Looks like our radius is 4. So immediately, brain says, go back to that equation. Our center is not at 0, 0, so no, we know this is the translated version. So we're thinking x minus h, quantity squared, plus y minus k, quantity squared, has to be equal to our r squared. Hopefully that's memorized or getting close to it. So now plug your values in. Start thinking about what your equation would look like. And I'll reveal momentarily. Got it written down, or at least in your head? Did you have x plus 2 quantity squared plus y minus 3 quantity squared equals 16? If you did, you nailed it. Let's try another one. This one will be a little different, but similar to something we did when we did parabolas. You're given an equation. It appears to have extra terms in it, but notice right away you have an x squared and a y squared. And it is the only equation that we've studied in conic sections that allows us to have an x squared and a y squared. Now somebody says, well, if you remember that first section when we were graphing them, ellipses also did. Yeah, but there were other numbers, remember. So right now we've got x squared plus y squared with no other coefficients in front of them. But we do have that extra term. And the bad guy really right now is looking like that negative 8x, okay, an extra term. So thinking about what we've done in the past, completing the square, etc., it says state the coordinates of its center and give its radius. Well, right now we sort of have to assume that we're probably going for something in the form of x minus h quantity squared plus y minus k quantity squared has to equal that radius squared. If we don't go under that assumption, then we got to go back and say, well, it's right-centered at 0, 0. Until we can prove that it is or isn't, that's what we're searching for. So I believe with our x squared and our y squared here, and that x being the extra term, if we put the x squared with the negative 8x, and maybe move the 7 to the other side as a number we don't need, we'd be looking at an equation like this. X squared minus 8x, so the like variable terms together, plus the y squared has to equal -7. It's getting better already because we put the x's with the x's and the y's with the y's. So we rearrange the terms. Highly suggest. Now, if we thought about sliding that down and saying, hey, if we complete the square, we could get some parentheses into this. So we're looking at just that middle term. So when we say, what are you looking at? It's that negative 8x. So half the middle term, -4, squared is 16. That 16 is what you see being added to both sides. Again, this is a balance. Without adding it to the right side, you cannot add it to the left. Without not adding it to the left, you can't add it to the right. So we completed the square. Now look real carefully what that does to the left-hand side. Go back and rewrite it as a perfect square. If you have a binomial that's a perfect square, you can shorten it. If you have a trinomial that's a perfect square, you can shorten it and rewrite it as that binomial. Remember, it's half the middle term, that quantity squared. The y squared we didn't touch. It didn't have any extra terms. It's still sitting there nice. But the 16 and the -7 do get simplified to 9. You look at that, it matches our equation up here. And you just have to identify what is that center and what is that radius. So you could do that now from your given equation that's in the translated version. So let's double check and see if you got them. Take a look. What do you believe your center is now? And what do you believe your radius is? I think that's what's next. Did you get a radius of 3 and a center at 4, 0? And then being able to graph that, obviously you came over to 1, 2, 3, 4, and from there marked your radius of 3, 1, 2, 3 to the right, 1, 2, 3 to the left, 1, 2, 3 up, 1, 2, 3 down. You were accurately able to draw a quick sketch of what that graph looks like. So I think you have all the tools you're going to need for circles. Definitely much simpler than your parabolas. Parabolas you're going to keep working on. They have a lot more detail to them. We like circles. So if you have any questions on them, missed something, bring those to class, please.